Alright, so this video we are going to look at finding the inverse of a 2 by 2 matrix. Uh, in this one I'm going to show you how to find the inverse using a kind of a shortcut, this formula here. Uh, I'll probably post another one. I know I'm going to post one on a 3 by 3 doing it the long way using the identity matrix, and I might post one on a 2 by 2 using the identity matrix, but for now I'm going to just do the formula here. So if we have a 2 by 2 matrix, the inverse is, well, look, you see the A and the D, you swap them. That's all you do. You swap the A and the D, and then you change the sign in front of the C and B. Just change the sign. And then that's all multiplied by 1 over A times D minus B times C. See, A times D minus B times C. Alright, so the only kind of matrix that's going to have an inverse is a square matrix. That means it has the same number of rows as it does columns, like a 2 by 2, a 3 by 3, or a 4 by 4. But not all square matrices have an inverse. Okay, a matrix that does not have an inverse is called a singular matrix. And I'll show you one that doesn't have an inverse. One of the examples I'm working here doesn't have an inverse, so and you'll know how to spot it. Well, let's look at this first. And this is how we represent the inverse with that little exponent there, minus 1. That means the inverse of matrix A. And matrices are usually represented with capital letters. Alright, so let's go ahead and find the inverse. So the inverse of A is equal to 1 over, okay, so it's A times D, so A times D, that's this diagonal, so 2 times negative 1, 2 times negative 1, minus B times C, B times C, so 4 times 1, 4 times 1, times, and then what do? We swap the A and the D, so we swap the 2 and the negative 1, so that's negative 1 and 2. And then we change the sign of these. So this would be negative 1, negative 4. Alright, and so that's going to give us 1 over, and that's going to be negative 2 minus 4 times negative 1, negative 4, negative 1, 2. And so this is going to give me what? 1 over negative 6, so negative 1/6 times negative 1, negative 4, negative 1, 2. And then what I'll do is I'll take the negative 1/6 and I'll multiply it to each element. So negative 1/6 times negative 1, that is 1/6. Negative 1/6 times negative 4 is 4 over 6. Negative 1/6 times negative 1 is positive 1/6. And negative 1/6 times 2 is negative 2 over 6. And then what we'll do is that's going to give us 1/6 and 1/6 here. And then this is going to give me what? 2/3 and negative 1/3. I just reduced the fractions. You could have reduced it right here. That would have been fine. But there's your matrix. Your matrix. There's your inverse. Alright, now let's look at this one. So, we've got A inverse is equal to, well, that's 1 over, so it's A times D, so 3 times 4, minus B times C, 6 times 2. And then what do? We swap these two, so that's 4, 3, and then change the sign of these, so that's negative 2, negative 6. And I know the ones that we changed the sign on, they're both positive and they both change to a negative. If that was a negative 4, it would change to a positive 4. Okay, you just change the sign. And so this A inverse, that's going to give me what? 1 over 12 minus 12, 4, negative 6, negative 2, 3. And so that's going to give me A inverse is equal to 1 over, 1 over 0. Well, we can stop right there. The 1 over 0, you can't have 0 in the denominator of a fraction. So this matrix right here has no inverse. And that's how you can tell if you get a 0 here. All right. Basically what it is, it's called the determinant of a matrix. I don't know if you've been introduced to that term or not, but that's actually what that is. A times D minus B times C. But just know if this goes to 0, then the matrix doesn't have an inverse. So I hope that helped. Check out the 3 by 3, find the inverse of a 3 by 3, and then I may post the longer way to go about this using the identity matrix, so you can check that one out too. Alright, so thanks for watching. Give me a like, share, and subscribe, and see you later.